Yes, question 7. Lots of reading and thinking here. I think I'm going to start thinking about what the volume of the gas is in total, because you started with 500, and then we're putting some in, and we're putting 50 in per hour, aren't we? So that's 50 T after T hours, but there's some leaking out. There's 20 T leaking out. So the total volume in the tank, and this is a mixture of helium and oxygen, is equal to that. Now, some of that's helium, some of that's oxygen. So the fraction of oxygen, so the oxygen in the tank is that fraction X over 500 plus 30T. That's the fraction of the proportion of oxygen that you've got in the tank. Now, the oxygen's going in, isn't it? We want to say how much is changing. So dx by dt, how much oxygen's going in? So you've got just start with 5% of 50. So there's your 2.5. But then it's leaking out. And the leaking out is 20 times by how much actual oxygen as a proportion. So look, this is 20 coming out, and this is the proportion of which is oxygen. So I've got 2.5 minus, and that is 2x divided by 50 plus 3t, cancelling a 10 both sides. And that is what we were trying to show. So it's how much is going in, take away the bit coming out, and the bit coming out was more complicated because we had to think of it as a proportion of the whole thing. So this is a first order differential equation, isn't it? I've just got dx by dt plus 2x over 50 plus 3t equals 2.5. It's not a separable variables, though. It's a integrating factor, and we're going to integrate 2 over 50 plus 3t, aren't we? dt. So what does that integrate to give? That integrates to give 2/3 the ln of 50 plus 3t. And my integrating factor is going to be e to the power of that. So if I put the 2/3 up the top there, so my integrating factor is going to be 50 plus 3t to the power of 2/3. So going back up here, I've got 50 plus 3t to the power of 2/3 dx by dt plus 2x, and now that'll be 50 plus 3t to the minus 1/3 there, equals 2.5. Let's get rid of all of that because I'm making a right mess of this, aren't we? So this is the product of 50 plus 3t to the power of 2/3 times by x. Is it? Yeah, it is. And then integrating this bit here, so I mean that should really be there, but integrating this bit here, we're now going to get 5 over 3 there, aren't we? Let's just check all of that. I think I'm just getting a half out there, aren't I? Yeah, I think that's right. So I'm going by 3/5. I'm dividing by that 3, and there's already a 2.5 up there. So that just tidies up to be a half. Yeah, we're in a right mess here, but I'm not changing it. So equals the integral of that. Right. Plus C. Yeah, things are all over the place, but let's have a think of that. Yeah, so now let's divide both sides by all of that. So that is going to give us a half 50 plus 3t. That's nice because they've just gone now, plus c over 50 plus 3t to the power of 2/3. Putting in when T is equal to 0, there's no oxygen at all, is there? If T is equal to 0, where X equal to 0, let's work out what C gives. And I'll confess I just cheated on there, so I've got C as minus 339. And so now, last bit, put in what happens at 4 hours. So at T equals 4, T equals 4, I've got 9.34 centimeters cubed. Yeah, it wasn't exactly 0 when I put the 0 in, but if I put the 4 in, as we were just asked to here, I'm getting the 9.34. And criticize the model at the end here. I suppose the critical thing here, it's nothing to do with putting the big numbers in. It's just simply that we're assuming the oxygen and helium mixes immediately, and probably that's unlikely, depending on who it was. 6 and a bit minutes. If you're still watching, sorry at